input our answers before I close off, and then we start going through. So let me just switch screen in the meantime. Alright, so these are our questions. We're going to be going through them shortly. So again, for persons who are still completing, I'm giving you just a few more seconds before I close off submission, and then we start going through. So I'm still giving a few more seconds. I'm not gonna go past 5:25, because I'm still seeing persons submitting, so I'm just allowing those submissions to come in before I close off, and then we start going through. Alright, so we're going to start going through now. So if you did not get to submit within the time, I would have closed off the submission, so you won't be able to submit at this time. Alright, so we will begin going through these questions. Alright, so we have our first question up, and as we're going through, if there are any questions, if you need further clarity as it relates to any question, please utilize the chat option or the mic. You can open your microphones and ask your questions, or you can post them in the chat. I will check the chat ever so often and respond to your questions. Alright, so let's go with this now. So we have our first question. It says we have this number 3.1415926 expressed to two significant figures. So they want us to indicate what this would be to two significant figures. So again, we have to pay attention to the terms that are used in this question. So it says two significant figures. Now, that simply means that we must be able to recognize what digits in a measurement are significant. Now, there's a rule which says that all digits that are not 0 are significant. Now, in this case, now we see that we have all non-zeros, so it means then that all of these are, in fact, significant. Now, we want to express this number right here to two significant figures. So how we do that is we start from left, or we start from our left most significant digit, and in this case, everything is significant, so we can start with the left digit. So we're going to see that 3 is significant, right? And as we continue, after the decimal point, we see we have 1. 1 is significant, so we have these two as two significant digits. Now, before we can write our answer, we have to look to see, okay, what follows our second significant digit. In that case, we have a 4 that follows. So since it is less than 5, we're going to keep this digit as 1. If it was 5 or more, then we would round up. So in this case, now our answer would just be 3.1, which would correspond to A. So number 1 therefore now would be A. Number 2 now says an example of a vector quantity is. So for this question, we have to be able to be familiar with what quantities are considered to be scalar quantities and what quantities are considered to be vector quantities. So a vector quantity will have magnitude as well as direction. So from the list right here, we can identify which of these quantities will have magnitude as well as direction. Now we should be able to recognize displacement right here as both magnitude and direction, because when we define displacement, we define it as the distance traveled in a straight line taken in a particular direction. So we're going to see that our vector quantity in this case now would just be displacement. So that's C for number 2. And again, as we're going through, you're allowed to ask questions. Number 3 now says, which of the following instruments is suitable for measuring the diameter of a human hair? Now, in this case, since human hair, it has a very small diameter, right? So we want to use an instrument that has the highest precision. Now, the best instrument right here to use in this case would be our micrometer screw gauge. So we're going to go with D for this one. So that's question 3. Question 4 now says, item 4 refers to the following diagram which shows two forces X and Y applied onto an object. What should be the magnitude and direction of a third force which will cause the object to remain stationary? So we have these two forces X and Y. They are directed towards the right. Okay? So X and Y are pushing this box to the right. Now we want to keep this box stationary, right? Which simply means that we want to keep it still. Now we should remember that for an object to be stationary, the net force must equal to.
Sir,
Yes.
you can go back to number 2. Let me see answer, please.
2. Number 2 will be C.
Okay, sir.
Right? So if the object is stationary, the net force must equal to 0. Right? So if we have these two forces X and Y applied to the right, in order for us to have a net force of 0, we must have a force acting in the opposite direction. Right? So let's just indicate that. So this would be our third force, must be acting in the opposite direction, which would be to the left. So our answer could be A or B. Right? Now, again, as we said, the net force must equal to 0. So these two forces going to the right must be equal to this force going to the left. So what we see then now is that this force right here must have a magnitude of X plus Y. So we're going to say X plus Y to the left, which is going to correspond to B. So number 4 then now would be B. Number 5 now says, which of the following is a derived unit? So we have to remember that derived units are formed when we multiply or divide base quantities, or derived units are formed from the multiplication and or division of base units. Now, from our list right here, we see that Kelvin, or K, which represents Kelvin, is a base unit, which is the base unit of temperature. We have S, which is for second, which is the base unit of time. We have the cubic meter right here, which is the SI unit of volume, right? And we have kilogram right here, which is the SI base unit of mass. Now, since we have volume right here, volume is formed by the multiplication of length, right? So the volume is really length cubed, right? So we're multiplying length by itself 3 times. So as a result, it is formed by the multiplication of the base quantity, length. So therefore, we're going to see that for number 5, our derived unit is going to be the cubic meter, which is C. Number 6 now says, a block is allowed to fall freely towards the ground. As it falls, its gravitational potential energy. So as the block is falling, we expect its height to decrease. So what we're going to see now is that the gravitational potential energy that the body has due to its, well, gravitational potential energy that the block has due to its height is going to be converted. And the reason why we know it's going to be converted is because we know that energy can either be created nor destroyed. Okay? So it's going to be converted. So the block is going to be falling, and as it falls, it's going to increase its velocity. Right? It's going to increase its velocity. So what we see now is that the gravitational potential energy then now will be converted into kinetic energy. So number 6, we have to go with D. Right? Number 7 now says that item 7 refers to the following diagram, which shows a section of a thermometer. What is the reading shown on the thermometer? So they want us to determine the reading on this right here. So to find the reading, so we see we have 80 right here, and we have 90, and we see that we have 1, 2, 3, 4, 5 divisions from 80 to 90. Now, if we take the difference of 80 and 90, we're going to get 10, right? And if we now divide by the number of divisions, which is 1, 2, 3, 4, 5, we're going to get 2. So each of these divisions is 2. So if we have 80 right here, we're going to have 82, 84, 86, and then 88. So we're going to settle with A for number 7. Now, next question now is number 8. And again, as we're going through, feel free to ask questions if there are any questions. Number 8 says, which of the following is the unit of momentum? Now, momentum is simply the product of an object's mass and its velocity. So mass, we know, is measured in kilogram, and the velocity is measured in meter per second. So when we multiply kilogram and meter per second, we should get kilogram meter per second, which would correspond to B. So number 8 then now would be B. So we continue. Alright, so that's 8. Number 9 now says a stable, well-designed racing car must have. So it says stable. Alright. So for an object to be stable, we know that the lower the center of gravity, the more stable the object will be. So for it to be stable, it must have a low center of gravity. Alright, so our best option in this case now would be A. So number 9 is going to be A. Number 10 now says that the diagram below shows a scale. The diagram below, drawn to scale, represents two forces S and T acting at O. In which of the following diagrams is the resultant in the direction OX? So, as we look at our options right here, right, they want us to determine which of these would have the resultant along OX. Now, OX is along the horizontal, as we can see right here. Right? So, in order for the resultant to act along the horizontal, what we're going to see is that both forces must have the same magnitude. Right? So, for the resultant to act along the horizontal, both forces must have the same magnitude. Now, we can denote, or we can relate the magnitude of a vector to the length of the arrow that is drawn. So if the magnitudes are equal and the length represents the magnitude, then the length of the arrows must be equal. So we can just simply look to see, okay, which of these we have the, what's it called again? The arrows, which represent the magnitude of the vector, being equal. And we see that that is straight away just option A. So this has to be number 8, number 10 has to be A, which is this right here. So that's number 10. Number 11 is where we go next. It says, which of the following formulae could be used to find the average speed of an object? So we should recall that average speed is simply defined as the distance traveled divided by the time taken. So from our options right here, we should be able to look for the one which says distance traveled divided by time taken, which is going to be C. All right? Now, as we look at other options, change in velocity over time is for acceleration, right? Change in displacement over time is for velocity, right? And distance traveled multiplied by time taken. Let's see that now. This is no unit, right? Distance traveled multiplied by time taken. Let's see that. No quantity is found by this, right? No quantity that we are aware of. So our answer then now is obviously C, so we settle with that. Number 12 now says, which of the following measuring instruments is suitable for measuring the diameter of a human ear? We see this question before, earlier, so we can just select the micrometer screw gauge. The same questions, but the answers, would have been shifted around somewhat. Number 13 now says, when two bodies collide, momentum is conserved. This means that, so when momentum is conserved, we simply say that the total momentum before collision is equal to the total momentum after collision. So from our list right here, right, so the best option would be D, which says total momentum of the bodies before impact is equal to the total momentum of the bodies after impact. So we're going to go with D for number 13. And then we continue. Number 14 now says a single force which can replace and have the same effect as two or more forces acting together is known as the, so we have resultant, equilibrant, moment, and we have vector. Now, when we talk about a single force, right, or generally speaking, a single vector that has the same effect as multiple vectors acting, we should be able to recognize that that is what we refer to as our resultant. So number 14 now, we're going to go with A, which is the resultant. Number 15 now says a balloon full of hydrogen accelerates upwards in air.
Wait, excuse me, what was 14?
14 is A.
All right.
Resultant. Number 15 now says that a balloon full of hydrogen accelerates upwards in air. Which of the following statements would be true? So option 1 says that the hydrogen has no weight. We know this is going to be definitely false, right? Because hydrogen gas will have a mass, and once there's a mass and it's in a gravitational field, it will have a weight. So one is false. Now, whenever we have questions like this, where we are given some options and we need to select which of them are correct, we can apply elimination technique. So we say that one is false, so it means then that this one is not a part of our answer, right? So our answer could either be B, C, or D. So we now have a greater probability of selecting the correct answer. So that's about 33% chance of selecting the correct answer if we have to rely on just a guess game. Now, option 2 says that the hydrogen exerts a resultant upward force on the balloon. All right, so the hydrogen exerts a resultant. All right, so I'm hearing a question. Yes, question, please.
So what was the answer for 14?
14, let's go back to that one. So 14 we said was the resultant, right, which has the same effect as two or more forces acting on an object.
Okay, thank you.
So hydrogen exerts a resultant upward force on the balloon, right? So let's see that now. So we have that option right here. We're going to come back to that. Now, part 3 now, our option 3 says that the weight of air displaced is greater than the weight of the hydrogen-filled balloon. So the weight of the air displaced is greater than the weight of the hydrogen-filled balloon. Now, we should recall that the weight of the fluid displaced by an object is what we refer to as the upthrust, right? Upthrust. So what we're saying now is that the upthrust, therefore, now is greater than the weight of the hydrogen-filled balloon. So the upthrust is greater than the weight, so it must accelerate upward as what we are told right here. So this is true, right? So we know that option 3 is true. So it means then that this is out of our option. So now we narrow it down now to 50% chance. So we can have a 50% chance of selecting the correct answer. Right, so we select this one was not so. So we need to go back to this one now. So number 2 now says that the hydrogen exerts a resultant upward force on the balloon. Right? What do we say about this statement? Anybody wants to weigh in on what they think about this statement right here?
Well, sir, I think it's true.
It's true. The hydrogen exerts a resultant upward force on the balloon. Right? So let's see. So what we're saying basically is that with the hydrogen inside the balloon, it is exerting a resultant upward force, which causes the balloon to rise. Now, if we really take a close look at that statement, again, what this is saying is that the balloon is able to apply an upward force on the hydrogen is applying an upward force on the balloon. Now, why would you say that? I mean, for the person who said that this was true, why would you say that?
No, at first I thought like since the hydrogen must have like some kind of weight in it, because that is what will accelerate it upwards.
Okay. All right. Well, I was considering that you were maybe thinking of it in the sense that, okay, since hydrogen is a very light gas, it will tend to rise, right, when compared to the surrounding air. Now, what you have to recognize in a case like this is that while the hydrogen gas, it is light, so we expect it to float compared to the surrounding fluid, which would be air. It is not a case that, okay, because hydrogen gas, it is light, it can actually apply upward force. The reason why there's an upward force on the hydrogen-filled balloon is due to the upthrust of the surrounding air. So due to the different densities of the two substances, the fluid in which the balloon is suspended will exert an upward force, which causes it to accelerate upward. So option 2 now would be false, right? Because hydrogen does not exert an upward force on the balloon. Again, it is due to the surrounding air that is actually applying that upward force. So our correct answer then now would be 3 only, which would be C. Alright, so if we're comfortable with that, we can move on. If we're still not comfortable, we can ask the question and then we can see how best we can clarify this.
Yes, sir, comfortable now.
Okay, good. Alright, so number 16 now says that the rate of which of the following determines the power of a machine. So we have doing work, converting energy, or changing temperature. Now we know that power is the rate at which work is done, or the rate at which energy is converted. So we can say that, okay, options 1 and 2 are true, right? Now option 3 now says, and first of all, since you say 1 and 2 is true, then anything that has just 1 or 3 only, well, let me not. Yeah, this one will be out as well, right? So this is going to be not true. So again, we can narrow it down to these two options. Now option 3 says change in temperature. Now when we're measuring power, we do not consider the rate at which a substance changes temperature, right? So this right here would be false. So our best answer would be 1 and 2 only, which corresponds to C. So that's number 16. So we go to 17 next. Now 17 says that the rate of which of the following is not true. Again, I think this question is worded properly. I think it should say which of the following is not true about the moment of a force, right? So which of these is not true about the moment of a force? So let's see now. So it says that it is measured in unit of Newton meters. So since moment of a force T is equal to the force multiplied by the perpendicular distance D, force is in newtons, distance is in meters. So indeed, this would be Newton meters. So this is true. It is the amount of force needed to keep a body turning. We're going to come back to that. It is a turning effect that a force has when it acts on a body. This is true. It is a product of the force and the perpendicular distance of its line of action from a point. So this is also true. Right, so then our answer, which is not true, would be B.
Excuse me, sir.
Yes.
The answer for number 15, what was it?
15 we said was C, as in cat. Okay. So that's number 17.
Sir, what about B? Because when I check the internet, I kind of
So B for this one?
D as
D?
in dog.
Okay, so again, as we said, when it says that the hydrogen exerts a resultant upward force on the balloon. Now, what we say now is that the reason why there is that upward force on the balloon is due to the upthrust exerted by the surrounding fluid. Right? Because if we were to think about it this way, let us say that we would have removed, let's say we place the balloon in a vacuum. Right? If we place the balloon in a vacuum, the balloon will not accelerate upward. Right? The reason why the balloon accelerates upward is due to the upthrust that it experiences by the surrounding air. Okay? So that is why we would have considered this option to be false. Alright?
Okay, sir, thank you.
Yes. Alright, so I'm still taking a second look at it. So it says that the hydrogen exerts a resultant upward force. That. No. Right? Again, upward force is again due to the surrounding fluid. Right? And again, it says that we have a balloon filled with hydrogen and it accelerates upwards in air. Right? So we have to just be a little bit keen in terms of what's really taking place right here. Right? So that's that. Number 18 now says, item 18 refers to the following diagram, where we have these three balls, X, Y, and Z. So it says X, Y, and Z are three balls of equal mass whose centers lie in a straight line. Y and Z are touching one another as shown. X, traveling with a velocity of v meters per second, hits on Y. Assuming that the spheres are perfectly elastic, the resultant motion after impact will be. So what we want to determine is what will happen to the balls after X collides with Y and Z. Now in this case, we have to consider, so it says that the spheres are perfectly elastic. So if they are perfectly elastic, it means that the total momentum, so let's say P total before must be equal to the P total after. How can I write that? So let's say total P before.
Sir,
Yes. Total.
sir, what's the answer for number 18?
Is it working on right now? So the total momentum before must be equal to the total momentum afterwards. Now in addition to that, it says that it is perfectly elastic. So once a collision is said to be elastic, or in this case perfectly elastic, the total momentum is conserved, as well as the total kinetic energy. Now in order for the total kinetic energy to be conserved, what we must observe, or what we're going to observe, is that okay, right? So in order for the total kinetic energy to be conserved, we're going to see that one of the balls must move off with the same velocity that the initial ball X was moving with. So what we're going to see now is that X and Y are going to remain stationary and Z is going to move off with velocity V. So our answer in this case now, as what I guess someone was indicating, would be B. X and Y both remain stationary and Z moves off with a velocity of V meters per second. So we're going to go with B for this one. So that's that question.
Wait, so I have a question for that one, right?
Yes, yes.
If it have like a constant velocity, right? Wouldn't all of them end up moving?
Again, we have to consider that total kinetic energy must be conserved, right? And if all the balls are moving, then we're going to have the total kinetic energy, let's say KE, total is going to be equal to a half m. I guess let's assume that, okay, they're moving with the same velocity. Then we're going to have the total kinetic energy being a half 3m times v squared, right? That is after. But the kinetic energy before is going to be a half mv squared, right? So
Right.
it's not going to be the same. So the total kinetic energy after and the total kinetic energy before will not be equal. So it will not be elastic.
Okay, all right, I understand.
Yes. All right, so that's that now. So number 19 now says a solid object X floats in mercury and sinks in water. A solid object Y floats in both mercury and water. Which of the following statements is true about X and Y? So it floats in, what do they say, floats in X? No, X floats in mercury, right? But Y floats in both mercury and water, right? So again, X floats in mercury, but it sinks in water, right? But Y floats in both mercury and water. So it says, which of the following statements is true about X and Y? So X is less dense than Y, right? We have X and Y are both denser than water, right? This is not true. This is not true because it said that Y floats in water, right? So it cannot be more dense. X and Y are both denser than mercury. So let's see this now. X floats in mercury, Y floats. So X and Y are both dense. So this is not so. X is more dense than Y. So let's see now. X floats in mercury and sinks in water, right? But Y floats in both. So therefore, this would be true, right? Because again, X floats in the mercury and sinks in the water. So it is dense. Y floats in both, so it's going to be less dense. So X is more dense than Y. So our answer, confirmed, would be D. 20 now says absolute zero is the temperature at which, and our options are air changes to a liquid, a gas would exert no pressure, all substances contract to zero volume, or a gas molecules move at constant speed. So let's see what it says right here. So absolute zero, which we know is the lowest possible temperature, right? Lowest temperature. Alright, so it says air changes to a liquid. This is not so. A gas exerts no pressure. All substances contract to zero volume, or gas molecules move at constant speed. So again, absolute zero is the lowest possible temperature, and temperature is a measure of the average kinetic energy. So if it is that our temperature is zero, then the average kinetic energy would be zero. So the molecules will not be moving. So that is false. So our answer then now would be either B or C. So let's take a closer look at B and C. So B says a gas would exert no pressure, and C says all substances contract to zero volume. Now our best answer in this case would have to be B, right? B is our answer right here, which says that a gas would exert no pressure. Now C says that all substances contract to zero volume. Now that is not true, right? Because it says all substances. So if we have, let us say, a block of metal and we cool it to absolute zero, it will not contract to zero volume. So C is not valid. All right, next question now says, 21 says, a pressure of a fixed mass of gas is P and its volume V. What is the new volume if the pressure is increased to 2P at constant temperatures? So we have constant temperature. So we should think about Boyle's law for this one. So we should think about Boyle's law for this question. Now, it says that what is the new volume if the pressure is increased to 2P? So we increase the pressure, right? And Boyle's law says that pressure and volume are inversely proportional. So if we increase the pressure by a factor of 2, then the volume must decrease by a factor of 2. So in this case now we're going to see that the volume is going to decrease by a half, or V over 2. So 21 would be A. 22 now says that the heat capacity of a body depends on, So again, we can recall heat capacity C is equal to M times C. So the heat capacity is dependent on the mass and the specific heat capacity. So our answer then now would have to be A for 22. So again,
Excuse me, sir.
yes,
What was 20 again?
20 again. Let's find 20. 20 is this runner, so that's B.
All right, thank you.
All right, yes. So 22 was A just now. Now 23 now says that some molten naphthalene at 100 degrees Celsius is allowed to cool down to room temperature. The naphthalene has a melting point, sorry, it should be if naphthalene has a melting point of 80 degrees Celsius, which are the following?
Sir,
Yes?
sir, what is 20 answer?
20?
No, 21.
21 is A.
Okay, sir, thanks.
Right? Yes. So it says if naphthalene has a melting point of 80 degrees Celsius, which of the following best represents the cooling curve? So in this case, we want to say the cooling curve. So since the naphthalene has a melting point of 80 degrees Celsius, it's going to change from a liquid to a solid at 80 degrees Celsius. And that occurs at a constant temperature. So best graph that shows that is C. So 23 is C, as what we see right here. Now 24, as we continue, says that the specific latent heat of vaporization of water is the energy required to change 1 kilogram of water at. So latent heat means that there is no temperature change, right? So the answer could either be this one or this one. Now, since we're talking about vaporization, right, of water, water transitions from a liquid to a vapor at 100 degrees Celsius. So the temperature is going to remain constant at 100 degrees Celsius. So our best answer would have to be C for 24. So 24 is C. 25 now says, which of the following graphs illustrates the variation of pressure with volume for a gas obeying Boyle's law? So we saw that earlier. We said that volume and pressure are inversely proportional. So we're going to look for the graph which shows inverse proportionality, which is D. So we're going to go with D for this one, since we plot pressure against volume, right? So since it's pressure against volume, answer would be D. Now, sometimes they might allow you to see pressure plotted against the inverse of volume. If that is the case, then B would be valid. But in this case now, since we're plotting just pressure against volume, again, the correct answer has to be D. So that's 25, 26 now. A gas is much easier to compress than a solid or a liquid because the gas molecules. So in this case now, we say the gas molecules are numerous, are arranged randomly, are moving about rapidly, or have no forces between them. So the reason why we're able to compress a gas much easier than a solid or a liquid is because of the forces between the molecules. So since the molecules are so far apart, the forces between them are very weak, right? Or we could assume to be negligible. So therefore, our answer in this case now would have to be D. So 26 is D. 27 now says a fixed mass of gas at constant temperature is compressed. The molecules of the gas will. So our options are hit the sides of the container more often, have more kinetic energy, move more slowly, or have more momentum. Now from our list right here, so we compress the gas, right? So the space is going to be smaller. So if the space is smaller, then the molecules, therefore, will be able to hit the sides of the container more often. So 27 would be A. And we continue with 28. 28 says that which of the following waves? Okay. 6 already? 6 o'clock? Okay, let's go, continue. Which of the following waves has the greatest amplitude? I want us to go through one more paper. So maybe we actually extend this beyond 7. So hopefully by 6:30 we can complete this question and then start the next paper. Okay, so we'll give an answer for this one. 28, largest amplitude would be C indeed, because amplitude is just from the rest position to the crest or the highest point. So this is going to be C for that one. Now 29. Which of the following would be the basic difference between a transverse mechanical wave and a longitudinal mechanical wave? Right, yes.
Sir, can I see question 27, please?
27, sure. 27 is this one. I will say it.
Thank you.
Yes. Now 29, we said no. Okay. The main difference between transverse mechanical wave and longitudinal mechanical wave. So we know that transverse wave, the particles oscillate perpendicularly. Longitudinal waves, the particles oscillate parallel. So let's see now the direction of the vibration of the particles. So this is true, right? So option 2 is true. So that means that we can take out that, right? So we're either down to B, C, or D. So let's see now. Option 1 says the medium through which they travel. So since we're talking about mechanical waves will require a medium for propagation. So we cannot use the medium as a means of distinguishing them because they both require a medium. So this is not true. So let's take out this one now, right? Now, 3 now says the wavelength. Now, it says which of the following would be the basic difference between a transverse mechanical wave and a longitudinal mechanical wave. So we have wavelength right here. So again, we're looking for the basic difference. So the basic difference between a transverse mechanical wave and a longitudinal mechanical wave would not be dependent on the wavelength, right? Because again, it says basic difference. So wavelength is going to be out. So therefore, our answer then now would narrow down to just D. All right, so almost there. So number 30 now. In which of the following groups are the electromagnetic waves written in order of increasing frequency, starting with the lowest? All right, so let's see what we have right here. So we want to have increasing frequency, starting with the lowest. So we can recall our electromagnetic spectrum: gamma rays, X-rays, ultraviolet rays, visible light, infrared, microwaves, and radio waves. Now, we have frequency increasing towards the left, right? So, radio waves would have the lowest frequency. So, our answer then now could either be C or D, right? Now, based on our list right here, we see that X-rays, right, compared to the list that we have right here, X-rays would have the greatest frequency. So then now we can just narrow down to D, right? So we have the radio waves, then the infrared, then ultraviolet, then X-rays. So 30 would be D. So let's see if we can go a little faster. 31 now says, this is what we have. Item 31 refers to the diagram below, which shows a longitudinal wave where C and R represents compressions and rarefactions respectively. If lambda equals the wavelength, the distance between C1 and R2 is, so from C1 right here to R2, we want to know what is that distance. Now from C1 to C2 would be a wavelength, and from C2 to C3 would be another wavelength. But since we're going from C2 to R2, that's going to be halfway, so it's going to be a half of a wavelength, right? So we're going to have one wavelength plus half a wavelength, which is simply 1.5 wavelengths. So that's C for 31. 32 now is where we go next. It says, which of the following or which of the statements about sound is not correct? So A says sound is transmitted as transverse wave. This is not true. And the question says which is not correct. So we have to go with A for 32. Everything else is correct right here, so A is not correct. Alright, 33 now says a ray of light in air strikes a glass block at an angle of incidence of 0 degrees. The light will be, so if the angle of incidence is 0 degrees, what we're going to see is that the angle of refraction is also going to be 0 degrees. Alright? And again, angle of incidence is 0 degrees, so the angle of refraction is 0 degrees. And this is not because the angle of incidence is equal to the angle of refraction. It is simply because the refractive index n is equal to sine I over sine r. Now, if we determine sine r, we're going to have sine r is going to be equal to sine I over n. Now, if I is 0 degrees, we're going to have sine of 0, which is 0, divided by n. 0 divided by n is 0. So what you see then now is that if the angle of refraction is going to be 0, then the ray will simply run along the normal, right? So if the ray is running along the normal, it simply means that if we make a sketch, something like this, so if this is our normal, like that, and we have our ray running down like that, incident, what we're going to see now is that it's going to continue along the normal like that, undeviated. So 33 then now would be A. 34 now says, in a longitudinal wave, the particles, so we spoke about this earlier, the particles, they will oscillate parallel, right? So they move back and forth, backwards and forwards, parallel to the direction of the wave. So 34 is C. 35 now says, in a projector, the slide is 5 centimeters from the lens, while the screen is 500 centimeters from the lens on the other side. What is the magnification? All right, so magnification, let's work that out, is equal to the image distance divided by the object distance. Now in this case, now we're told that the slide is 5 centimeters from the lens. So from the lens, the slide is 5 centimeters, so that represents our object distance, which is U, right? And we're told that the screen is 500 centimeters from the lens, so that's going to be our image distance, which is V. So in this case now we can say V is 500 centimeters divided by U, which is 5 centimeters. Divide that out, we're going to get that goes that, so we're going to get simply 100, and the units cancel off. So our answer in this case now will have to be B, 100. Alright, so 36 is where we go. Well, 35, let's do this 35 question. So this was a duplicate question. Which of the diagram best shows the path taken by the ray of light through the rectangular block? So we're going to have refraction taking place. We're going from air to glass, so less dense to more dense. So we should refract towards the normal, right? So A looks like a potential answer. This shows no refraction, so we're going to ignore that. C also looks like a potential answer, right? D also looks like a potential answer, right? So let's kind of narrow down now. So we know refraction takes place. Well, let's look at A now. So we have refraction taking place now. Then all of a sudden, the ray now decides to go in this direction. So this, even though it's a potential answer from what we see right here, it ultimately fails due to that what happens at this point right here. What happens right here, so we can ignore that. So the answer then now would be C or D. Now, what we should see now is that after the ray emerges, it must travel in the same direction as our original ray. So the best answer now would have to be C. So even though this wasn't a question that you would answer, just wanted to answer it right here for us. So now we are at 36, which says, which of the following can produce a diminished virtual image of a real object? Right, so it says a diminished question.
Sir, what is number 32 answer, please?
32 answer, let me find that for you. Right here. 32 answer. Okay, so 32 was further up. That would be A. Right, I'm seeing a comment.
Can you show 35, please?
Repeat?
Can you show 35 answer, please?
35, yes. So 35, we have two 35 in fact. This one was B, right? And then this one now we said was C, right?
Okay.
36 now says, which of the following can produce a diminished virtual image of a real object? So this is a diminished virtual image of a real object. All right, so it says diminished, but it's virtual. Now, we have a plane mirror. A plane mirror produces a virtual image, but it's not diminished. So let's take out that. So let's take that out and take that out. Right? Now, option 2 now says we have a diverging lens. Now, a diverging lens produces a virtual image, that is diminished. So this is true. Now, a converging lens now can be used to produce a diminished image, but it is going to be real. So a converging lens produces a real diminished image. So this one is not so. So it means then that we settle with B, 2 only. So 36 was that. 37 now says, item 37 refers to the following diagram which shows an object placed in front of a plane mirror. Which of the following images best represents the position of the object produced? So the image in a plane mirror, it is laterally inverted, right? So left becomes right, and it is going to be upright. So our best option in this case now would have to be upright. So let's say it's going to be either D or A, but since A shows lateral inversion, we're going to settle with A. So 37 is A. 38 now is where we go next. It says when a polythene rod is rubbed with a cloth, it becomes. So whenever we have questions like this, all we need to focus on is just electrons. So let's take that out, cross out that, because we're talking about protons, cross out that one as well. So we're down to either B or C, right? So B says it becomes negatively charged by gaining electrons. C says it becomes positively charged by gaining electrons. Now, we know that electrons are negative. So if we're gaining electrons, we must become negative. So the answer must be B for 38. 39 now. Which of the following diagrams represents the magnetic field existing between two opposite magnetic poles? So, opposite poles, they attract, right? So the ones that show attraction is either A or B, because C and D shows repulsion. Now, we know that magnetic field lines, they always emerge from a north pole, right? And they always converge at a south pole. So they go outward from the north pole and they go inward to the south pole. So the one that shows that is A, because we have the field lines going out from the north pole and going into the south pole. So 39 is A. 40 now says, which of the following relationships between electrical quantities is correct? So we have V is equal to P times I. This is not true. We have R is equal to V times I. Not true. We have Q is equal to E over V. Alright, so we're saying that charge Q is equal to energy per unit volt. Right? And we have E is equal to V times I. So, well, E is equal to V times I. This is not true. So if we're able to recognize this, we're going to see that, okay, this is actually true. Because this comes from our definition of the potential difference. So potential difference V is the work done or the energy converted per unit charge. So if we make Q the subject, we get Q is equal to E over V, which is what we have right here for C. So that's 40. So we say 41 is next. 41 says, which of the following objects can detect X-ray? So X-rays can be detected by photographic films. So this one is B for number 41. Number 42 now says, which of the following is not one of the ways in which the strength of the magnetic field near a solenoid, which is a long coil carrying a current, can be increased? So we can increase the strength of the magnetic field by increasing the current, by increasing the number of turns per unit length, or by placing a soft iron. So the only one that is not valid is A, and A in fact contradicts B, because if we're increasing the current, if we're increasing the resistance, that's going to cause the current to decrease. So 42 would be A. 43 now says, which of the following statements is/are true about the image formed by a plane mirror? So the image formed by a plane mirror is indeed virtual. It is laterally inverted, but it is not magnified because it is the same size. So we have 1 and 2, so that's B for 43. Now 44 says, which of the labeled paths A, B, C, or D in the diagram below is correct for the ray X, Y? So we have XY traveling like that. It's going from air to glass. So we're going to undergo refraction. So it's going to refract. So if we consider a normal at this point, let's make that black. So if we consider a normal at this point perpendicular, we would expect the ray to undergo refraction. So it's going to refract such that it moves closer to the normal. So this one looks to be continuing straight. B continues straight, so we're going to ignore that. So that is not so, that is not so. So it could go something like that, right? Or it could go something like this. Now, at this point right here, at this boundary right here, at the boundary here, we're going from glass to air, so it should undergo refraction. Now, in this case, it should refract away from the normal because we're going from more dense to less dense. So what we see now is that in this case, for C, it is refracting away from the normal like this. So the answer is indeed C. So that's 44. No, 45 says that total internal reflection in glass occurs when? So total internal reflection occurs if we exceed the critical angle. So that's going to be B for 45. I'm going a little bit fast. So, but if you have questions, let me know. I'm trying to catch the 6:30 mark so we can start going through the next paper. Now, number 46 now says, which of the following circuit symbols represents a fuse? So a fuse is what we're looking for. Now, A shows a diode. B is indeed the fuse. So B is our correct answer. This one right here shows a lamp, right? Or a filament, not a lamp, right? Or a bulb. And D right here shows what we call a galvanometer, right? So that's 46. 47 now says an ammeter has a very low resistance so that it can be placed. So we want to have a ammeter having a low resistance. Somebody have a question? Please go.
So can you please go back to question 45?
45, yes. 45.
Okay, sir, thank you.
So 47 now says an ammeter. So an ammeter is always placed in series. So it's either B or D. Now place it in series so that it does not affect the circuit when it have a very low resistance. So we're going to go with B for 47. 48 now. Which of the following materials is most suitable for the core of an electromagnet? So the most suitable material for the core of an electromagnet is indeed. So 48 is D.
We said C was 47.
47.
Sir, what was 47?
47 is B.
Okay.
Right? So 48 now is D, and in 49, the following diagrams labeled 1, 2, and 3 shows the magnetic field lines plotted by a student. Which of the following are correct? So we have these field lines going from north to south, so this is correct. We have these field lines going outward from the North Pole and they repel, so this is correct. In this case now we have the field lines going from north to south, so this is also correct. So we have 1, 2, and 3, so this number, which is 49, is D. Alright, so number 50 now, as we get 10 minutes left. Number 50 now says, which of the following voltage time graph best represents an AC voltage? So AC,
Sir, what is 49?
49 is D. Right? So AC voltage changes direction. So we're looking for the one that oscillates between the positive and the negative, or oscillates about the zero line, which would be D. So AC would correspond to D for number 50. 51 now says, which of the following circuits will the lamp light up? Alright, so which of these will the lamp light up? Alright, so we have a diode, right? So for the diode, this is positive, this is negative. So this is the positive of the battery. Sorry, my bad, what am I doing? This is the negative of the battery, and this is the positive. So we have negative connected to positive, so this is in reverse bias. So this will not, current will not flow, right, for that one. For B now, this is positive, this is negative, this is positive, this is negative, so this is forward bias. So we're going to have current flowing through the circuit, so therefore this lamp will be able to light up. In this case now, we don't know what's going on right here, this will not light up. This, you don't connect a battery like that, so this will not light up. So 51 would be B. So let's continue quickly. 52 now says, item 52 refers to the following diagram. Which of the following options shows the correct match of the component, name, and its number? So 1 is our lamp, 2 is our fuse. So let's see that now. So 1 is the lamp, right? 2 is the fuse, right? 3 is the diode, and 4 is the resistor. So 52 is going to be A. 53 now says, item 53 refers to the following diagram of a simple AC generator. Now it says the parts labeled X in the diagram are known as so these looks like rings, right? So they are in fact called slip rings, right? Slip rings. So 53 would be D. Now number 54 now says that isotopes of an element differ from each other in that they have different isotopes have same atomic number, right? But different mass number. And the difference in mass number is due to the difference in the number of neutrons. So we're going to have different number of neutrons. So 54 is C. 55 now says, which of the following graphs shows how the activity of a radioactive source varies with time? So how activity varies with time. So our answer in this case now will naturally be D, right? Since we expect the activity to decrease in a nonlinear manner as time progresses. So 55 is D. 56 now says, according to Rutherford Bohr model of the atom, of a neutral, stable atom, if n is the number of protons, n is the number of neutrons, p is the number of protons, and e is the number of electrons in the atom, then for all elements, since it is neutral, number of positive protons must equal to number of negative electrons. So P must be equal to E. So 56 would be B. 57 now says, which of the following symbols would be possible for an isotope of the nuclide represented by this symbol right here? So since we have same atomic number, Z must be the same. So the only one where that is the case is D, right? So Z must be the same, but the mass number could be +2, right? So our correct answer for 57 is D. So we're getting there. 58 now says an isotope of uranium 34 changes to thorium-230. This is an example of, so since our mass number reduces by 4, atomic number reduces by 2, this is an example of an alpha decay. So 58 is C. 59 says, which of the following scientists discovered radium? So radium was discovered by the female Marie Curie. So 59 is A. Now 60 says that a radioactive isotope has a half-life of 20 days. How many days will it take for a given sample to have its activity reduced to 1/8? Alright, so we can show this. So if we start with 1, after 1 half-life it's going to go down by a half, then a quarter, then it's going to go down by 1/8. So we're going to have a total of 1, 2, 3 half-life periods. Now each half-life is 20 days. So 3 times 20 would give us 60. So our correct answer then now would be B, which is 60 days. So those are our questions, right, for this paper. Hopefully we're able to get some clarity with questions. Now, what we're going to do now is we're going to work another paper like this within the time. So our first question, am I on mic? Yes, mic is up. So the first question says, errors due to parallax can be minimized by. So we can reduce parallax error by simply placing our eyes at right angles to whatever mark that we need to read. So this question, number 1, would be B. Right, so place your eyes at right angle with the mark. Number 2 now says, which of the following measuring instruments is more suitable for accurately measuring the volume of 40.2 centimeters cube of a liquid? So we have our options right here. We have burette, pipette, beaker, and we have the measuring cylinder. Now in this case, we can consider that, okay, the beaker will not allow us to accurately take this measurement, so we can take that out. The pipette, it has a limited capacity, which is about 25 centimeters cube, and we're going for 40.2. So we can take that out. So we're down to the burette or the measuring cylinder. But again, we want to accurately measure 40.2 centimeters. Now a measuring cylinder increments by 1. Right? So a measuring cylinder increments by 1. So therefore, in this case now, we're not going to be able to get 40.1 with a measuring cylinder. So the most, or the best answer, or the best option, or the best thing to use would be our burette. So that's number 2. Number 3 now says, which of the following changes can be caused by a force acting on a body? So we want to know which of the following changes can be caused by a force acting on a body. So we know a force can cause a change in the shape. It can cause a change in the motion, right? Now, we can also consider that, okay, the force can cause a change in the volume. Now, since the volume would have changed, then its density will also change, or can also change. So, in this case now, our answer would be D for number 3. Number 4 now says that the mass of an astronaut is 70 kilograms when standing on the moon. When he returns to the Earth, his approximate weight will be. So, for this question, we must be able to recall that weight is equal to the mass multiplied by the gravitational field strength. Now, the mass of the man is 70 kilograms. Gravitational field strength of the Earth is 10 newtons per kilogram. So, multiplying these two together, we're going to get 700 newtons. So, number 4 then now would be D, newtons.
Excuse me, number 2. Okay, I see it.
Oh, okay, good. All right, so that's number 4. Number 5 now says that the moment of a force is defined.
So what's the answer for number 4?
4 we say was D. Okay, so D for number 4. Number 5 now. The moment of a force is defined as, we would have seen this question before. So once we see a question that we're familiar with, we just look for the answer, the product of the force and its perpendicular distance, and we select the correct answer. Number 6 is also a familiar question. We would have seen it from the previous paper that we were working. So in this case now, to keep this stationary, and again, we have to apply a force in opposite direction. So we're going to apply it to the left, x plus y, so that we have the same magnitude, but opposite direction. So we're going to go with B for this one. Number 7 now says, when a force F is applied to a spring of original length L, the new...
Sir, excuse me.
Yes.
Question, go back to question 6.
6 right here.
Oh, it's going.
All right, so again, the question is asking, what force must we apply to keep this stationary? So to keep this stationary, we must apply an opposite force, which is applied to the left. So the third force must be directed to the left to keep this stationary, and it must have the same magnitude as our 2 forces that were acting to the right.
Okay, thank you, sir.
Yes. So we'll go with that. So number 7 now says, when a force F is applied to a spring of original length L, the new length becomes L plus X. What would be the length of the spring if a force of F over 2 is applied? So when we apply F, the spring extends by X. So if we apply F over 2, the spring must extend by X over 2. So now in that case now, the length of the spring will be its original length, L, plus the extension, which is X over 2. So that's going to be D for number 7. Number 8 now says, item 8 refers to the following graph of a light spring, which shows a simple extension versus force graph. Which of the following statements is/are true? So one says the elastic limit of the spring was exceeded. We clearly see that is the case because our graph starts to curve upward towards the extension axis. So this one is true. The elastic limit was exceeded, so this is true. So any option that doesn't have 1, let's just take it out. Right, like that. Number 2 now says that the spring obeyed Hooke's law over its entire extension. Now, if we agree that 1 is true, right, that the spring, if we agree that the elastic limit was exceeded, then the spring will not obey Hooke's law over the entire extension. So this is false. So we can take out option 2. So anywhere we see 2, let's just cross it out. Right? And we can cross this out as well, because we saw, well, as a matter of fact, no, we will cross it out because it is true. Let's go again, let's fix that. So we cross out what is not true. So 2 is not true, so let's cross it out. So that 1 was true, right? So let's check option 3 now before we can decide on our final answer. So number 3 says that the force per unit extension in the elastic region is 7.5 newtons per centimeter. So if we divide the force of 75 newtons and the extension of 10 within the elastic region, we're going to get 7.5. So 3 is also true. So then it means then that for number 8 we have to go with B. Number 9 now says the kinetic energy of a body of mass m and velocity v is given by. So we must remember kinetic energy is a half mv squared, right, which is the same thing as mv squared over 2, which corresponds to B. So 9 is D. 10. Which of the following will be constant if a constant net force is applied to a body? So a constant net force always produce a constant acceleration. And this is from Newton's second law, F is equal to m times A. So m for the object is going to be fixed. So if we apply a constant force, then we're going to get a constant acceleration. Right? So that's 10 is C. 11 now. Item 11, this looks like a familiar question. So it says on the point X. No, it doesn't. I don't know. I don't think we did this before. Did we? Don't remember. Item 11 refers to the following velocity time graph, which shows a ball being thrown vertically upwards from the ground. The point X on the graph shows when the ball is. So point X right here, we see that we have velocity of 0, and that is after about 3 seconds. So this right here represents the ball being at maximum height above the ground, because at maximum height its velocity is going to be 0, as what we see right here. So it's going to be at the highest point above the ground, so that's going to be A for number 11. 12 now says a falling raindrop reaches a constant speed when. So again we have the raindrop reaching constant speed. So if the speed is constant, then the acceleration is going to be equal to 0, right? So it's not accelerating. Now if acceleration is 0, then F is equal to ma, and A is 0, so F must be equal to 0, where F right here is our net force. So if the speed is constant, then the net force must be 0. So our answer, which reflects that, is A, which says that there is no net force acting on it. So we'll go with A for number 12.
Sure, what was the answer for 11?
11 we said was also A. Number 13 now says, if an object is moving along a surface with a constant acceleration, the net force acting on the object is, so this is similar to the one above. So constant net force, well, constant acceleration, so it must have a constant acceleration. Constant acceleration, so it must have a constant net force. So net force must be constant, so 13 is going to be B, as in boy. Now, number 14 now. A glass marble.
So what was 12?
12 we said was A.
Yeah.
Okay. Alright, so 14 now says a glass marble X moving with a speed of 6 meters per second collides head-on with an identical stationary glass marble Y. What is the velocity of Y after collision, assuming X is brought to rest? Alright, so if X is brought to rest, then its momentum after collision is going to be 0. Now, the total momentum before collision must equal to the total momentum after collision. So before collision, X was moving, Y was stationary. Momentum of X, well, X will have momentum, but Y will not. So after the collision, if X is now stationary, so it has no momentum, then Y must gain, or Y must have the same momentum that X had before the collision. Now, they say that we were talking about identical stationary, identical marbles. So, if it is that X was originally moving at 6 meters per second before the collision, If y moves off when x is stationary, then y must move with that same velocity for the total momentum to be conserved. So that's going to be C for 14. 15 now, the rate of which of the following will determine the power of a machine. So we said before that this was doing work, converting energy. So 1 and 2 only, so that's C. It's a familiar question, or we saw it before I should say. Which of the following implements is/are designed to take advantage of a large moment provided by a relatively small force? So first, to get a large moment, right, provided by a small force, we must have the lever arm being significantly large. So we just identify which of these involve a large lever arm, or in other words, we see that the force applies at a very large perpendicular distance from the pivot, which would be for our claw hammer or crowbar, as well as our wire cutters. So that's 1, 2, and 4, which is going to be D. Number 17 now says that the upthrust experienced by a solid immersed in a liquid is equal to, so the upthrust is always equal to the weight of the volume of the fluid displaced. So in this case now, we're talking about a liquid, so the upthrust must equal to the weight of the liquid displaced, so that's going to be C. Okay, so it's equal to the weight of the volume of the fluid displaced. Now look at B. B says the volume of the fluid displaced. So it's not that the upthrust is equal to the volume, but instead it is equal to the weight of that specific volume of fluid that is actually displaced. And also, since upthrust is a force, it's going to be measured in newtons. Weight is also a force measured in newtons. So, and again, even from that, I mean, we can just determine the answer, because upthrust is in newtons. Which of these is in newton? Because they are equal, so they must have the same unit. And C is the only one that supports that. All right, number 18 now says, a piece of string is tied onto a small stone and the stone is then suspended, totally immersed in water. The tension in the string will be, so what do we want us to find? I want us to find out what will be the tension in the string. So since this is suspended in the fluid, so if we have our stone like this, suspended in some fluid, let's say something like that, we're going to have an upward force, which is our upthrust, and we're going to have our weight acting downward. Now, since it is being supported by this string, there's going to be a tension along the string, right? Now, the tension, T, will be acting upward along the string. So then now, what we see now is that the tension plus the upthrust, U, because they're in the same direction, must equal to the weight going downward. Sum of upward forces must equal sum of downward forces. So in this case now, the weight of the stone now, right? So it says now the tension, in the string. So we want to know what would be the tension. So in this case now, we can make T the subject. So T then now is going to be equal to W minus U. So the tension then now must be less than the weight. So in this case now, we can say tension is going to be less than the weight. So that's going to be C for that one. 19 now says, a solid object when placed in a beaker of water just sinks to the bottom. Which of the following should be done to make the object float? So we have cut in part of the object. If you cut off part of the object, that will not do anything to allow it to float. So let's take that out. So let's cross out cross out A and cross out C. B now says, option 2 I should say, says dissolving a lot of salt in the water. Yes, we can do that, and that will increase the density of the water and make the object have a greater probability of floating. 3 now says carry the beaker up the top of a high mountain. This will not do anything to allow it to float, so we cross that out, so we're going to be stuck with B for number 19. Number 20, as we continue. And again, as we go through, if persons have questions, can post in your questions. So we're now at, this is number 20 now. 20 says that 24 centimeters cube of air at a pressure of P millimeters, P millimeter mercury, are trapped in the syringe which is blocked at X. The piston is forced to the 8 centimeters mark. The new pressure in terms of P is, so two ways you can look at this. we can look at this and it says assume temperature is constant. So if temperature is constant, then again, we need to think about Boyle's law. So Boyle's law says that pressure and volume are inversely proportional. So if we reduce the volume from 24 to 8, we must expect the pressure to increase. So the pressure must increase. Now A says the pressure is going to be P over 3. Since we say the pressure increases, then we can take that out because that is not so. Now, in this case, now we move the volume from 24 to 8. Right? So we would have reduced the volume. Now, we can show this by calculation. Right? So let me just word the calculation for this just quickly. So for Boyle's law, we know that P1, V1 is always equal to P2 times V2. We're trying to P2 times V2, not V2 times V2. So P2 times V2. So we're trying to find P2. So P2 is equal to P1 times V1 over V2. So P1 is just P, right? So let's call that P. V1 is 24 cm cube. So that's 24 cm cube. And V2 is 8 cm cube. So that's 8 cm cube. So that goes with that. 24 into 8 into 24 is 3. So we're going to have 3P or 3 times P. So what we see then now is that P2 is going to be equal to 3P. So our pressure then now, once we would have do that, is going to be 3P. So we could show that by calculation, or we could just simply consider that, okay, we're reducing the volume from 24 to 8. That's a reduction of 4 or a factor of 4. Sorry, what am I talking? We would have reduced by a factor of 3, my bad. So the volume reduced by a factor of 3. So the pressure must increase because volume and pressure are inversely proportional. So the pressure must increase by a factor of 3. So we're going to get pressure being 3P. So 20 is B. 21 now says 21 now says in the pressure law, which of the following would be true? So for the pressure law, it says that the ratio of pressure to Kelvin temperature is constant. Yes, this is true. Volume is constant, also true, but the pressure is not constant because if one is true, then this cannot be true. Right? So 21 is going to be 1 and 2, so that's C. 22 now says, which of the following are characteristic features of a clinical thermometer? So a clinical thermometer will have a narrow constriction in the tube just above the bulb. It has a limited range of temperatures and it also has a large bore. So we can have the mercury being more visible. So 22 is going to be D. So again, if we have questions with these, don't be afraid to ask. 23 now says, which of the following are reasons why a hot liquid placed in a double-walled vacuum flask retains its heat for a long time? So a double-walled glass, vacuum flask, double-walled vacuum flask, right? So the space in between the glass is a vacuum. Space in between the double wall is a vacuum. So it says that evacuated space between the double walls reduce heat loss by conduction. That's a true statement. Silver in the walls reduce heat loss by radiation because it's going to cause thermal energy to be reflected because silver is a good reflector of thermal energy. So this is true. The silvered outer walls help to absorb heat from the surroundings. That's not true. So 1 and 2 is true. So which one is that? That is A. So we'll go with A for that one. Alright, so that will be A for 23. 24 now says, which of the following would be the unit of the heat capacity of an object? So heat capacity, the unit is the joule per Kelvin. So that's C, joule per Kelvin. 25 now says, which of the following is true of evaporation?
Excuse me, sir.
Yes.
Can you go back to 23, please?
23, yes.
All right, thank you.
Yes, good. So 23 is that. 24 was C now. 25. Which of the following is true of evaporation? It occurs throughout the liquid at no definite throughout liquid. That's
Wait,
not
so
so.
24 is C or D?
C, 24 C. So this is not so. It occurs at the surface of the liquid at no definite temperature. This is true. So let's say we don't want to know which one is true. So find what is true. So let's agree to B being the answer. Now, next question says, when the volume of a fixed mass of gas is reduced at constant temperature, the average speed of the molecules. All right, so we reduce the volume at constant temperature. So we want to know what's going to happen to the average speed. Now again, temperature is a measure of the average kinetic energy. All right? So if the temperature is constant, then the average kinetic energy is not changing. And if the average kinetic energy is not changing, then the average speed will not change. So it says that average speed remains the same as the temperature is not changed or does not change. So we're going to go with A for this one. So 26 is A. 27 now is where we are next. So 27 says that the figure above shows a piece of ice. I think we see this question before. Don't remember if we did. But anyways, it says that the figure above shows a piece of ice wrapped in a copper gauze and submerged in a glass test tube of water. The water, when heated at the top, boils long before the ice is melted. The main reason for this is that. So the reason why the ice remains unmelted is because water is a poor conductor. So water is a poor conductor of heat. So let's go with D for that one. Number 28 now says, which of the following is the correct relation between the wavelength, speed, and frequency of a wave? So we know V is equal to F lambda. So we're just going to look for the one that corresponds to that. So this looked to be because if we multiply both sides by lambda, we're going to get V is equal to F lambda. So 28 is C. Next one now is 29. 29 says that the figure above shows a wavefront about to reach a reflecting surface XY. Which of the following would represent the wavefront after reflection? So after reflection, we expect the wavefront to look exactly as what we see in A right here. So number 29 is going to be A. Right? 29 is going to be A. Now, next question is 30. 30 says, whenever there is complete destructive interference between two coherent wave trains, the waves must be. So if we have complete destructive interference may look something like this. Let's say we have one wave like that. And let's say we have our other wave looking like this. So if these two waves interfere, we're going to get complete destructive interference. And what we see now is that these two waves, they're out of phase, right? They're out of phase by half of a wavelength. So for destructive interference, they must be out of phase by half a wavelength. So that's going to be B. If they're in phase, we're going to get constructive interference. Now C says out of phase by one wavelength. If they're out of phase by one wavelength, then they're going to be back in phase, right? And then D now says out of phase by a quarter of a wavelength. That's not going to cause complete destructive interference. So 30 is B. 31. Which of the following statements about sound is not correct? Not correct, they said. A says sound is transmitted as transverse. This is not correct because sound is longitudinal. So 31 is A. 32. In which of the following, so this one looks familiar to what we see before, in which of the following are the electromagnetic waves written in order of increasing frequency starting with the lowest? So we're going to go with radio waves, infrared, UV, and X-rays. So 32 is D. 33, which of the following is the reason why the diffraction of light is not usually observed? So diffraction, we can remember, is the spreading out of waves, right? Let's say we have these waves meeting this opening. They're going to spread out, right, into the region behind this opening. So this is what diffraction is. Now, for light waves, right, it says that why is it not observed? So, light waves, so in order for diffraction to occur, first of all, the wavelength of the wave must be larger than the opening. Now, for light waves, that's a very small wavelength. Now, compared to most of the things that we can see in our everyday life, the gaps that we can see, they're going to be significantly larger than the wavelength of light. So that is why it is not usually observed. So it is because of the wavelength being too small. So 33 is going to be A. 34. The table below lists the refractive indices of 4 different materials. In which medium would the light waves have the slowest speed? So light is going to have the slowest speed.
Sir,
Yes.
did you say the answer was for 33?
33 we said was A, as in apple.
Okay.
Yes. 34 now. What am I saying now? Which medium light have the slowest speed? So light will have the lowest speed or the slowest speed in the object that has the greatest refractive index, which would be diamond. So that's going to be D. 35 now. 35 is here. Which of the following would be true of the image of an object placed at the bottom of a tank of water and viewed vertically from above? So, if we just kind of sketch what's going to be happening right here. So let's say we have a tank with some water, and we have an object. Let's say we have this object right here. Let's say it's just a box, and we're viewing this object right here. What we're going to see is that this object is going to appear to be a little bit higher than it actually is, right? Now, this image, because again, what really happens is that when we have light rays traveling from this object right here, let's say we have a ray of light. Let's see if we can show that. We have a ray of light, let's say, traveling like that. Once it meets the boundary between the water and the air, it's going to undergo refraction. So again, let's put a normal. So we're going from, this is what again, more dense, which is water, to less dense, which is air. So it's going to refract away from the normal. So we're going to get something like that, if I can sketch it properly. We're going to get diffraction from the normal. Again, this is going this way, right? So now, what's going to happen now is that if we place our eye at this point right here, our eye will see this ray of light coming from this object right here. Now, our eye, or our brain I should say, knows that light travels in a straight line. So our brain is going to give a perception that the light ray is actually coming from this point right here. So that allows us now to see that this object is going to appear to be closer to the surface than it actually is, right? Now, since this is, again, formed by broken lines, because again, it is the fact that our eyes, or our brain knows that light travels in a straight line, so it's going to assume that the light rays are coming from this point. So what it means then now is that the image that we see is going to be a virtual image, right? It's going to be a virtual image. So what it means then now is that option 1 is going to be true, right? Option 2 says that it's going to be diminished. This is not so, right? Object will not be diminished. In fact, it's going to be larger. So this is going to be false. So 2 is false, and 3 is nearer to the eye than the object. We just said that a while ago, so that is true. So 1 and 3 is true. So that's going to be C. I'm not sure if that's a question somebody's asking. Go with the question if it is. Jamaica, have a question first. Alright, so we continue. 35 we said was C. 36 now says, which of the diagrams best represents the passage of a beam of white light through a triangular glass prism? So we should see dispersion taking place. So the one that shows that is C, because again we're going to have the rays splitting at this boundary, at the boundary right here, and they're also going to split at this boundary. So the best answer in this case is C for number 36. 37 now says that the image on the film of a camera is usually, so the image on the film of a camera, right? So we have inverted, diminished, and it's real. Now, what we should remember is that the image on the film is going to be a virtual image. Right, let's see that now. The image, let's go again. So the image on the film of a camera, right? Image on the film of a camera. So let's see that now. All right, so we have to pay attention to the wording of this. So let's just see if we can eliminate some stuff as we go through. So image, we know it's going to be inverted, right? So answer, you can take that out. Take that out. So it's either going to be A or B. So it says the image on the film of a camera. All right, so let's just kind of see what this is really asking. So they're saying that, okay, we take a film or a camera film, right? And the image formed on that film, right? We want to know its properties. Now, we know it's going to be inverted. We know it's going to be diminished, right? But is it going to be real or is it going to be virtual? So again, we're taking into consideration a film, right, that we would have taken out of a camera, and we're looking at the image on that film, right? So the image on that film, because we have light rays actually coming from it, it will be a real image. So for 37 now, we're going to go with A for this question. Any questions right here about this? Right. So 37 would be A. 38 now says the total internal reflection in a glass occurs. So total internal reflection occurs if the angle of incidence exceeds the critical angle. So the critical angle is exceeded, so 38, we'll go with C for that one. 39, again, this is a familiar question. So a ray of light in air strikes a glass block at an angle of incidence of 0. So it's going to be undeviated, right, inside the glass. So that's 39. Number 40 now says that the position of an image formed by a plane mirror depends on, so the image in a plane mirror depends on, or the distance or the position in this case of the image in a plane mirror depends on the distance that the object is placed from the mirror. So 40 is going to go with B. 41 now, which of the following expressions would represent the formula for linear magnification? So magnification is so again, magnification M is the image distance over the object distance, or magnification is equal to the image height. So let's say image height over the object height. Sorry. Image height over the object height. Like that. So in this case, now we say height of image over the height of object. This is true. Height of object over height of image, that's not true. Object distance over image distance, that is not true. So 41 would just be 1 only, so that's A for 41. 42 now says the figure above shows a cell E, a diode P, and a resistor R connected in series. The current through R is best illustrated by which of the following graphs? So right here we have a cell which is well, this side is going to be negative and this side is going to be positive, and this is a DC source, right? Now we have a diode connected. This side of the diode is positive, this is negative, so the diode is going to be connected in forward bias. So we're going to have a current flow through this resistor. So in this case now, since we have a cell, right, we're going to expect to get a direct current, which would be represented by this one right here. So we're going to get a steady DC because we have a simple cell right here. So that's number, what was it, 42. 43 now says the refractive index of a transparent medium with a critical angle C for light.
Sir, what is the answer you have for 42?
42 we said was C. So 41 now, 43 I should say. says that the refractive index of a transparent medium with a critical angle C for light traveling from the medium to air is, so the refractive index, now the refractive index N is equal to, well, first of all, again, I guess probably we need to erase that. So refractive index N is equal to sine I over sine R. Now, in this case, now we're told that the critical angle is C. So the critical angle is that angle of incidence that will cause an angle of refraction of 90 degrees. So in this case, now we can say N is equal to sine I. I is the angle of incidence, which is going to correspond to our critical angle. So we're going to have sine of I, which is, again, let me just verify this. So it says that it's going from medium, traveling from medium to air. It's going from medium to air, so we have to be careful with this. If it's going from medium to air, we say sine R, in fact, over sine I. So now, in this case now, this becomes N is equal to, so again, if the angle of incidence is equal to the critical angle C, then the angle of refraction R is going to be 90. So we're going to have sine 90 degrees divided by sine of the critical angle C. So we get now N is equal to sine of 90 over C, which would be C. Now, sometimes you might see this question where they have N is equal to, sine of 90 is 1, so we could have this as 1 over sine of C as well. So that's another way that this answer could be represented. So you can look out for both of them. 44. Which of the following appliances would require the fuse with the largest rating? So a fuse is used to limit the amount of current. So we need to know which of these devices will draw the greatest current. So if we look at this right here, so we have 10,000 watts and a voltage of 240. Now power is equal to I times V. So I will be equal to P over V. So if P is 10,000 watts and V is 240 volts, we can use a calculator for that. So let's say we get a calculator for that, and we say 10,000 divided by 240, 10000 divided by 240, that's about 42 amperes. Right, so that's 42 amperes. So if you look at the others now, this is 10,000, right? So it must be less than that because we have a less power. In this case now, this is 400 and this is 1500. So all of these will have less power, so therefore less current being drawn. So the largest fuse will be for D, which is going to require a fuse of approximately 42 amperes. So that's 44. 45 now says, in the diagram above, a piece of rubber magnet from a refrigerator is surrounded by a plotting compass. The rubber magnet has, so in this case now we see that our plotting compass are pointing to the sides. Now the needle of the compass, it always points towards the poles of the magnet. Well, point towards the pole or away. If it's a north pole, it's going to point, let's see, no, sorry, my bad. If it's a south pole, it's going to point towards the south pole. And if it's a north pole, it's going to point away from the north pole. So in this case now, since we see that these are directed or aligned towards the center, it simply means that the poles are at the center of this magnet. So we're going to go with B for that one. 46 now says, steel is not suitable for use in an electromagnet because, so let's see this now. So we know that steel is not easily magnetized, but once desmagnetized, it retains its magnetism very well. Now, in the case of an electromagnet, we need it to be able to be quickly magnetized and then quickly demagnetized, right? So, in this case now, it says that steel is not suitable, so and we have an option which says that it is too difficult to magnetize, it retains magnetism too well, it loses magnetism too easily. This is not so. It contains too many domains. This is unreasonable. So we're going to cross that out. So we're down to A or B. Now, as I said, with an electromagnet, we need it to be easily magnetized and then easily demagnetized. So A says that it is too difficult to magnetize. So in this case now, it will not be the best option to use for an electromagnet, because you need an electromagnet to be easily magnetized. So we're going to go with A for 46. So 46 is A. Then now we have 47. Hold on a second. Just check if there is any question. All right, so for the paper, this paper is not one year's paper. It consists of multiple years. Somebody was asking another question.
Can I see what is, please?
46, this one.
Thank you, sir.
Yes. All right, so
Sir, why isn't it B?
why isn't it D? Again, what we say now with an electromagnet, it needs to be easily magnetized, right? Now, because steel is not easily magnetized, then that causes it not to be the most suited choice for an electromagnet. Right, so let's see that now. So that. All right, so let me take another look at this. So again, yeah, I mean, reasonable question, because again, how I'm reasoning it out is considering that, okay, since the steel is not easily magnetized, but then again, if we take into consideration what is an electromagnet. So an electromagnet is just merely a coil in which we have a metal, right, through its center. Now, in the case of steel, right, in the case of steel, because it is not readily magnetized, right, it is not easily magnetized. So let's see something now. But then again, if we think about it from the context of, okay, when we have a coil like this and we pass a current through it, this will behave as a magnet. Now, when we place a metal, or for in this case, a steel inside this, what it does, it actually strengthens this magnetic field, right? So then, in the case of what we have going on right here, because again, we have to really look deep with these questions right here. So, with the case of the steel will actually strengthen the magnetic field inside right here, right? And also cause it to be, because it's going to cause it to be concentrated. Now, with the operation of an electromagnet, again, an electromagnet, we want to be able to turn on the circuit, and then we have a magnet being formed. Then as soon as we disconnect the circuit, we expect that magnet, or that magnetic field, to be disappear. So in the case of that now, again, let's see what it says now. It says steel is not used because it is too difficult to magnetize, or it retains its magnetism well. I'm going to be going with this, with B, and I'm going to tell you why we're going with B. So the reason why I'm going with B is due to the fact that, okay, again, with the steel inside the coil, that's going to make the electromagnet stronger, right? So steel is going to cause the electromagnet to become stronger. So it's going to allow this to be a good electromagnet once this being operated. But as soon as we disconnect the circuit, because steel has the ability to retain its magnetism, so what we see now is that the coil is going to cause the steel to become magnetized, right? Due to the current passing through it, through the coil. But as soon as we disconnect the circuit, the steel is going to actually retain the magnetism. So in fact, 46, now we're going to go with B for that one. All right, so are we comfortable with this? Okay. All right, so again, this paper is not one solid paper, it's multiple papers combined. So 47 now says two permanent what am I saying for this? Which of the diagrams above clearly illustrate the magnetic fields created as shown? Okay. All right, so let's see now. So north to south, yes, that is true. For this one now, we have two conductors parallel carrying current into the page. So the magnetic field around them is going to be anti-clockwise. Like that, again, we can determine that by using our right hand grip rule. So it's going to be anti-clockwise for both of them, like that. So anti-clockwise. No, that's not anti-clockwise, that's clockwise, my bad. It's going to be clockwise when we use our right hand grip rule. So clockwise like that. Now, this is going down, this is going up. So these two field lines are going to interact, and since they're going in opposite direction, they're going to effectively cancel out each other. So what we're going to see now is that these two conductors are going to tend to be forced towards each other. So the field pattern then now, we're going to get something looking like this, right, for these two current carrying conductors. So this would be true. So 1 and 2 is true, right? Now, for this one now, this is a solenoid. Now, when we have a solenoid right here, the solenoid will behave as if it's a bar magnet. So the field patterns right here. So in this case, let's see what happens now. So we have this one going from north to south outside the magnet, right? So let's see now. So it's going to go from north to south outside the magnet. And then now, so this one is going like that. So let's see what's really happening right here. So this is going from, well, let's say assume this is north to south outside the magnet. So it's going to continue around like this. And then go from, so again, let me just note. So this is north right here and this is south. So it's going to go from north to south outside the magnet. But inside the magnet is going to go from south to north. So it means then that this one is not valid. So we're going to cross that off. Let me just take a close look at this. So this is going in. Alright, so this is not so. So we're going to go with 1 and 2. So this is going to go B. Again, if you have questions, post them in the comments or ask your questions. 48 now says that rectification can best be done by using A. So rectification is best done when we use a diode. So 48 would be D. 49 now says that the diagram below represents a straight wire carrying a current into the plane of the paper. So if it's carrying current into the plane of the paper, then we would expect, again, we can take our right hand grip rule, so it's going into the page, so the thumb goes in and our fingers curl clockwise. So that's going to be D for this one. So 49 is D. 50 now says that the diagram above shows a typical relay. The part labeled P must be made of. So when a current flows through this is going to become magnetized, right? So we want to attract this part labeled P. So for it to be attracted by P, we want this to be made of iron, right? So that it can become attracted. So in this case now we're going to go with A for number 50. So we have 10 more to go. Now it says a flexible wire lies horizontally between the poles of a strong magnet as shown in the diagram above. When the switch X is closed, the wire moves. So in this case now we're going to have a current flow from positive to negative. So we're going to have conventional current going that way and then coming out like that. So if we now use our right hand grip rule, if we now use Fleming's left hand rule, right? So the index finger must point from north to south and the current is coming out. So our fingers are going to be like this. So the index will be like that. The second finger points out like that. If I can draw it properly, let me just use arrows. So this is your index finger pointing in that way. Your middle finger points outward because the current is coming out. And our thumb now is going to be upward. And the thumb represents the force. This is the field. And this is the current. So as a result of that, we're going to see that the force on the conductor is going to be upward. So we're going to have the wire moving upward. So this is number 51. So 51 is A. Alright, so 51 is A. 52 now. It is possible to induce a voltage in a coil by the use of A. So we can induce a voltage in a coil by considering a change in magnetic field.
Sir,
Yes.
sir. I said 51 is upward side.
Oh, and sorry, my bad. We're trying to go too fast, so this is upwards. Yes, indeed, as we said right here. So it's going to move upward. Good catch. All right, so it is possible to induce that by a change in magnetic field. 53 now says, which of the following statements about alternating current is true? It can be changed into direct current by a transformer. That's not true. It can be rectified by using a semiconductor diode. This is true. So 53 is B. 54 now is where we go next. It says for a simple DC generator, which of the following graphs will be produced by 2 complete rotations of the armature. So for two complete rotation, we're going to get 2 cycles. So we're going to look for the graph which shows 2 cycles. So we have 1 cycle like that, another one like that. So this is C for 54. 55 now says that no practical transformer is 100% efficient. Which of the following causes energy losses? So we're going to have energy loss due to resistance of the wire, which is going to cause heat, magnetizing and demagnetizing of the core, right? We're going to cause lose energy when the coil magnetizes and demagnetizes constantly. And 3 now, we're going to also have eddy currents, right, in the core. So all 3. So that's going to be D. 56 now. Yes, I hear a beep.
Excuse me, sir. What is eddy current?
Okay, so eddy currents, these are currents that are generated through a conductor, right, as it undergoes a change in magnetic field. So inside the transformer, we have some metal cores, right? We usually laminate them as a means of reducing the eddy currents. So once we have a change in magnetic field, we get a current. Now, because we have once we have a change in magnetic field associated with a conductor in which the metal is, there's going to be an induced current. Now, this induced current that is produced in the transformer, it is known as eddy currents, right? Because they are small currents that are produced inside the coil, not the coil, inside the core of the transformer. Okay? All right, good. So that's 55. 56 now says, which of the following would be possible symbols for an isotope of the nuclide represented by this? So we're looking for the one where Z is the same, which is this one and this one. So 1 and 2 only. So that's going to be D. 57 now says that the activity of a radioactive substance was measured at suitable intervals over a period of days. and its radioactive decay curve plotted. The half-life in days is, so the half-life is the time taken for the activity to reduce to 1/2 or to half of its original value. So if we go from 400, half of 400 is 200, so we just do a broken line like that, straight across to that, and then we go straight down, and that corresponds to 2, so that's going to be 2 days. So 57 is B. 58 now says that radioactivity takes place in an atom as a result of, so radioactivity is due to the nucleus of the atom being unstable, right, or due to nuclear instability. All right, 59. Several different types of emissions were directed at right angles to a magnetic field and emerged undeflected. The emissions consisted of, so if it's undeflected, then it means that it has no charge, because a magnetic field will always deflect a charged particle. So if it's undeflected, then it is uncharged or not charged. Now, from our list right here, we see we have gamma, which is uncharged. And again, we're talking about, what I said? Several emissions, okay? Several emissions. So it's going to be gamma. All right. Number 16. Which of the following statements about a proton is not correct? So it says it is an hydrogen atom minus an electron. This is true. It has the same mass as that of an electron. This is not true. So they say not correct. So this is true. This is not correct. Right, so B is not correct, so our answer is going to be B. All right, so that's our paper.
Sir, what was 57, sir?
50, what? 56?
7.
57 is B. 57 is B. All right, so
Sir, 58, please.
58 is A. Nuclear
Thank you.
instability.
Sir, we get to 53.
53 is this one, which is B.
And 54, sir. Please.
54 also C. All right, it's 54.
Thanks.
All right, so that's our paper. All right.
Sir,
Yes.
so you can upload it to document with the answer in the classroom, please.
Yes, I will share it in the classroom. Let me also just send the link. So those are our questions for this.
Wait, sir, is this session recorded?
Yes, it is.
Sir, are some questions on the end of the paper?
Repeat, please.
Like some repeated question, 41, 42 at the end.
At the end? Oh, yes. I think I deliberately did that, did I? Because I think I wanted us to go through them. All right, so let's see. Yes, good. All right, yes, good. Yeah, I wanted us to go through these. So let's do that. Yes. All right, so, okay. So these were some extra questions. Again, because as I said, I would have just taken questions from multiple papers and combined them. And I saw these questions and I wasn't able to find a way to place them in. So I said, okay, let me add them to the end so we can discuss them. So let's do that. Some bonus questions. So 41 now says, let me zoom in some more. So 41 says that, or this question says that in the diagram above, the incident rays of light are parallel. Where will the image of the object be formed? All right, so let's see this now. So we have these parallel rays, right? Now, what we should remember is that any ray that passes through the optical center, which is this point right here, it has to continue undeviated. So this one is going to continue undeviated. If I can draw a straight line. No. So this one continues undeviated like that. Something like so. Okay? So that's what we see right here. So we're going to have this ray going something like that. Or better yet, ensure that this is straight. So we want this to be as straight as possible. So it's going to be going something like so. Alright. Now hopefully, well, this kind of lean, but it would have continued something like that. Now hopefully we should see that, okay, since our rays, or since this ray passes through C, we would expect that the image is going to be formed at C, right? Image is going to be formed at C right there. Now, this ray, right? Again, let's see this now. Well, really and truly, once we find one ray, we can actually assume that all rays will actually meet at that point, because that is what a converging lens does. A converging lens causes light rays to meet at a point. So what we're going to see now is that our other two rays will refract and meet, something like that. Again, can draw a straight line, right? Something like that. And this one is going to go like so, right? That.
With, excuse me, where is called that point again where it have like the
Orange dot?
yeah,
That's
not
the
orange dot, the part where the two waves cut C.
Okay, that's the focus.
Focus.
Focus, right? So let's just see that and confirm, right? But again, in fact, if I just by citing this, I mean, it looks as if we were to, let's see if I can get a ruler. If we were to consider a straight line like that, let's just see. Okay, passes through C, but it doesn't pass through A. Right? Just wanted to ensure that these 2 points are not lining up. Right? So our answer then now we're going to settle with is C for this one. So this answer is going to be C. Again, still taking a second look. So this one goes like that. Right? So let's see, now this one is right here. So it's going to go like that. Okay. Well, as a matter of fact, this ray. Okay. All right. All right. So that's what we see. So we're going to get C for that. I was just verifying some stuff before we move. All right. 42 now says, which of the following gives the correct international color code for wiring a plug? Now, easiest one to start with is Earth. Earth is always green or yellow, right? So it means that that is not so, that is not so, and that is not so, right? Even though we say green or yellow, usually we mix them, green and yellow. That's what you're going to see most times. So our answer then now is going to be A, and that confirms us because live is always brown and neutral is blue. So that's 42. 43 now says that the force on a current carrying conductor in a magnetic field could be doubled by, so we can double the force on the current carrying conductor. It says half in the field strength, no. Reducing the current by a factor of 2, no. Increasing the current by a factor of 2, yes. So C is for this answer right here. Okay, if we double the diameter, we're going to, in fact, let's see now, that. So we want to double the force. If we double the diameter, so since resistance is equal to rho L over A, so we double the diameter, so we're going to have the area being larger, so this is going to be decrease, so resistance decreases. So let's see, let's just verify this double diameter of the conductor. So double the diameter. So it says to double the force, we can increase the current by a factor of 2. Right, so yeah, so C is correct. C is correct. Double the diameter of the conductor. Resistance is that. A is pi r squared. Oh no, so no. Doubling the diameter will not cause the resistance to be reduced by a half. Because again, it's the area, right? Not the circumference. So C is our correct answer for 43. Alright, so 44 now, last question, last bonus question. It says a positively charged particle X is moving at high speed in the direction indicated in the diagram above. In which direction will the magnetic field deflect the particle? So again, we have a positive charged particle. So the positive particle moving like that, and again, a positive particle moving is the same thing as conventional current, right? So we can apply Fleming's left-hand rule. So again, the index finger, my bad, points from north to south, right? The middle finger or the second finger points in the direction of conventional current. So conventional current is going into, because the positive charge is going into, so our index finger is going to go into that index finger, the middle finger. Index finger goes north to south, like that. Middle finger or the second finger goes into the page. So our thumb points downward, like that. So therefore, the field is going to deflect the particle downward. So this one is going to be C. So those are the questions. Right, those are the questions. Hopefully.
So explain how it goes downward again, please.
Right, so again, we use Fleming's left-hand rule. So if you take your left hand, your 3 fingers must be at right angles. So you want to have your thumb up like that, index finger out like that, and your second finger like that. So this is the force for the thumb, this is the field, and this is the conventional current. Now in this case now, the field is north to south. So we have to point our index finger north to south. But because the current is going in, we have to rotate our left hand, so that the index, again keep on saying index, so that the middle finger is pointing into, because that is for the conventional current. And what we see now is that our thumb points downward, so the force is going to be downward. Okay?
Okay, sir.
All right, so let me just save this and share with you before we close off. So hopefully we would have gotten something valuable from our discussion here. Hopefully we found this helpful. Hopefully it allowed us to clear up certain misconceptions that we might have had. Also, hopefully it would have reinforced what we would have prepared, or what we would have revised as we prepare for our paper tomorrow. Let me share that link for you. All right, so this is share. All right, so hopefully this, as I said, was pretty much helpful for us. All right, so we want to check 44. So 44, this number 44, we said it was C is going to be going downward. All right. Okay, so that's the link for.
Sorry, question. So didn't you say it was upward at first?
All right, so that was a different question. All right, it was a different question. Let's find it. So this one is different because in this case the current is coming out. Right, so since the current is coming out, that is why it is upward. But for this one now, it's a different scenario. The current is going in. So the direction of the force is going to be reversed. Okay? All right. So this was helpful. You can give me a thumbs up. Or the reaction, right? Or you can just react, I mean, if it was, I don't know if they have reactions for dissatisfaction, you can let that stop, right? All right, so again, I would have shared the link to the answer or solution, so you can access those to revise. First paper, let me share that one also. All right, so thank you guys for the reactions. As I said, really hope you would have found this helpful, and seem as if you would have, so that's good. Let let's see, copy. All right, yes, you guys are most welcome. It's always a pleasure to assist students with their preparations for exams. So all the best tomorrow. All right. Again, remember to take your time, read the questions clearly. If there's a question that you know you're unsure about, seek to eliminate possible incorrect answers or answers that don't make any sense, because you're going to find answers that are meaningless. So you can eliminate those answers and then narrow it down to at least 2, and then you can, if worst case, you just guess and you have 50% chance of actually getting the correct answer. So put these strategies into play. Spend some time reviewing what we would have gone through. Review your other past papers that you might have access to, right? And just give yourselves that optimum opportunity to do well on the paper tomorrow. So that's where we're going to close off. So again, thank you guys for joining. Thank you for participating. For those persons who did not get a chance to submit their answers within the time, hopefully as we go through, you would have gained benefit from that. So again, this is where we're going to close off. So thanks again and all the best.